So in this demonstration, I'm going to show you how to use 5 different analog sensors in this week's lab. You can see here the first program is designed to simply read a single sensor, and it's going to as it reads it, it's going to adjust the speed with which a particular LED is being flashed. In the circuit here, you can see that we've already connected power and ground, and I've gone ahead and pre-wired all 5 of the sensors. For this one, we're only going to use this sensor right here attached to the potentiometer. And so if you just keep an eye on this flashing LED right here, as I move it, as I rotate the potentiometer counterclockwise, you should see that the LED begins to flash more and more quickly. So it's flashing more and more quickly, and it kind of gets to be almost like a strobe. I'll stop that so nobody has a seizure. As we move more and more clockwise, then the light is going to flash more and more slowly, until ultimately when I get all the way clockwise, it's flashing with about 1 second on and 1 second off. So that's the very first measurement to do, or the very first experiment to run. Then we're going to add some additional content. We're going to be able to look at the serial monitor to see what's going on with each of these values. We're going to print the values from the serial monitor. So we can see here, if I open up the serial monitor, and I can adjust the potentiometer now. So you'll see that as I adjust the potentiometer, the value goes from 1023, that's the number in the first column, and it's going all the way down to 0. And if I rotate it clockwise again, then that number goes back up, and it can go all the way up to 1023. This flex sensor right here, which is hard for you to see because it's pretty much vertical. The flex sensor is the second column. What I'm going to do is I'm going to grab it by the base here so that I'm not going to break the sensor. And then as I bend the sensor, you can see that the middle column is going to change. So if it's totally straight, it's about 261, 260. As I bend it, it becomes maybe about over 500, 520, something like that. Interestingly, if I bend it the other way, it actually goes below 260. So it has a flex sensor that can detect bending in both directions. Just be sure to hold on to the base and don't bend it past about 90 degrees because they're pretty they're pretty sensitive to being bent. Then I have a light sensor, and the light sensor is the third column of numbers. It's this little photocell right here, and if you watch that third column, if I cover it with my finger, notice that number goes way up. So it was about 400, and then it went up quite a bit. And it looks like this potentiometer is loose. That's why that number is kind of jumping around there. So if I cover that up with my finger, you can see that the number in the third column changes. I can even shine a light on it. Now, if I were you, I would use your cell phone, but I'm using my cell phone to record this, so I can't do that. So I'm shining a different light, and you can see that I'm getting it down into the double digits. I bet you could get it down into 30 even if you were to use a different light on it. So as I turn the light off, you can see it goes back up into the 400s. And if I completely cover that sensor up with my finger, it's over 800. So we have the ability to detect rotation, the ability to detect a flex, and the ability to detect light. We can then add another sensor to this package, and that's the temperature sensor. So what the temperature sensor, which is this little gray device right here, does, whoops, oh, I'm already running the serial monitor, so I cannot also download a program. Okay, let's try this again. So this temperature sensor right here is going to have a resistance that varies with temperature, and then I can use that resistance variation to also detect a variation in voltage. So let's look at the serial monitor again, and now we should get 4 columns of numbers. And the fourth column, you can see that it's a pretty solid 460, but if I squeeze this between my fingers, you'll notice that it goes from 460 down to 420, 415, so 460 down to about, let's call it, I bet it'll get down to about 405. So I'll remember those two numbers, 460 down to 405, because those are 2 numbers that I'm going to need in the next part. Now I can still adjust potentiometer, and I can still adjust the flex sensor, and I can still adjust the light level. That potentiometer is still loose, but now I can also adjust this temperature sensor, 460 down to 405. Now your numbers could vary depending on the particular values that you use, or how warm it is, or how warm your fingers are. 460 down to 405. So what I'd like to do is I'd like to calibrate that as like a thermometer. And so I've got some values here. I'd like it to go between 720 and 900. So I'm going to adjust this to be 460 down to about 405. And so when I do that, I can now what's going to happen is I'm going to calculate the slope. And so you can see here, slope is going to be a floating point number. That means that it's a real number. It can have a fractional component. I'm going to calculate it as out hot minus out cool divided by n cool minus n hot. Now you might say, why did you break that across two different lines? Because you're going from integers, which have whole values only, to floating point numbers. If you don't do it in this way, breaking it up into two steps, then it'll actually round it to the nearest integer, and that's not what you want. So be sure to break it up as the description suggests. And then I'm going to use an equation here, which you're going to need to derive for yourself to convert from a non calibrated temperature value to a calibrated temperature value. So let's load this one up, and it's loading right now. By the way, this fifth one also adds the infrared values. So I have here an infrared transmitter and an infrared receiver. And you've got the circuit diagrams for those in the handout. And the transmitter, of course, is just sending, about a centimeter away to the receiver. So it should receive a nice, strong signal. So if I go to the serial monitor, I should have 5 columns of numbers. The 729, I wanted that to be about 720. If you blow on it, it actually cools it off a little bit, so I can get that down to about, now it's at about 70.6 degrees. It'll creep back up towards 72. But if I squeeze it, I was hoping that the calibrated thermometer would go up to about 90. And so we're at 85, 86, looking at the fourth column, 87, 88, 88, 89, and apparently my fingers are not warm enough. There's a 90. So it's right between 72.0 and 90.0 because we use that equation to calibrate it. Now the other thing that I wanted you to observe is that fifth column. Because the transmitter and the receiver are so close to each other, it's transmitting a nice solid signal. We're getting a low value of just 53. Remember that the full range is from 0 up to 1023. But I'm going to take a business card here, nice thick business card, and I'm just going to put this in between. So when I do that, you'll notice that the number jumps from 53 up into the 900s. So remember that 1023 is the highest that it can be, and we're darn close to 1023 right here. If I take the card back out again, 52. If I put the card back in again, back up into the 900s again. So this is how your garage door opener closer, more importantly the closer, can detect when there's a bicycle or a cat or a toddler in the way, and that's how it prevents the door from closing and hurting that person or that cat.